In this video, let's go through a brief learning guide on how to develop the skills and knowledge sets as a design engineer. So we have seen what is the importance of the design engineering role in the product development process and the economy, the larger picture. Then what do recruiters need from design engineers? Then what are the important skills which are required from design engineers? And then let's see how to develop those skills and knowledge sets. So the first and most important point is that learning is lifelong. It never stops. So if you're a design engineer and if you want to become better at solving problems and solve bigger problems, you need to keep on learning to innovate. So learning never stops. It is lifelong. Now over here, I have divided learning in terms of three sets. So that is knowledge, that is skill, and that is the mindset and approach. So knowledge is basically what are the concepts to learn, what are the facts to know. For example, if you are an engineer, you would have learned about engineering concepts like the Newton's first law of motion or Newton's second law of motion, third law. All of these are concepts which we learn and then which we apply to problem solving. And then there are certain facts which we have to consider as fixed, which do not change. So these are facts to know, that is essential knowledge to have as an engineer. Then comes the skills. Skills is developing an ability or a knack to do something. For example, driving a car is called as a skill, which you develop naturally. So if you're practicing it continuously, you will develop a natural skill at doing it. So that is termed as a skill. So that's a difference between knowledge and skill. Knowledge is something which you learn as a concept, which you learn as a fact or information. Skill is which you develop through practice. And then there is the mindset and approach, which is basically the whole thought process. So what thought process you are having in your mind when you are approaching a problem. So frame of mind and approach. This is a very important aspect because this governs everything else. If you are having the knowledge and skills, but you're not having the right mindset and approach, then you will not be able to arrive at the most optimal solution. Now, if we go through the various types of knowledge which are required for design engineers, here is a brief list. Of course, it's a much more expansive list, but these are the essential ones. So the knowledge of the design process, how to go about the engineering design process, what are the various steps, what has to be followed, what has to be done first, what has to be done second, third, fourth, etc. So that design process knowledge is important. Then engineering knowledge. The knowledge, the concepts which you learn in engineering, the engineering basics like mechanics of materials, strength of materials, the engineering mechanics, theory of machines, design of machine elements, etc. All of these are engineering knowledge which are learned as during the engineering studies. Then knowledge of materials. What are the different types of materials available which can be used in the design? What are the pros and cons? How does it compare and what all properties are required to be known to design effectively? So those are materials. Then there is manufacturing. So similar to materials, manufacturing processes should be known by the design engineer. What is the manufacturing process? What are the various pros and cons of different processes? And if I have to design for a specific manufacturing process, what is to be known? Then product related knowledge. For example, if I'm designing a product for a specific customer need, then what are those product requirements? That has to be known in detail. So if I'm designing a car, what is the product requirements from a car? So all of that knowledge has to be known for a design engineer to design effectively. Then there are specific skills, specific knowledge sets like DFMEA process. So if you are making a DFMEA, then I should know what is the process for making a DFMEA, what are the steps to be followed, what are the concepts to be known. So these are the various knowledge sets required from a design engineer. Of course, this is not an exhaustive list. This is just a list to give you a flavor of what is called as knowledge. There can be many specific things relating to different domains for design engineers which have to be learned in terms of knowledge. Then there are skills. So here is a list of essential skills. As we have already seen, concept development is a very important skill. So we can develop the concept development skill through continuous practice. So let's say if there are specific problems or specific improvements which can be made in design. So you take up that as a challenge and then develop concepts to improve the designs. So that practice of developing concepts for improvement or for solving a specific problem, that becomes an inherent skill with practice. Similarly, with generic problem solving as well, using the theoretical method as well as the practical method, both when applied to generic problem solving will become a skill which will come naturally for a design engineer when approached with similar types of problems. Third one is CAD, which is very obvious. CAD is a very important skill for design engineers, both 3D modeling and 2D drafting. So developing the visualizations in 3D space as well as 2D is very important skill. Complex geometry requires more complex skill sets. So this is a no-brainer. Then there is of course engineering drawing, tolerancing and GD&T. Now this is a very important skill because once the engineering drawing is made, it will go to the manufacturing and inspection team, and their job is to derive information from that engineering drawing and do their job. So if the engineering drawing has been made in a very ambiguous fashion and does not convey information clearly, then there will be errors, there will be defects in the product, in the quality of the product, because the manufacturing team and the design team might not be in the same page. They might have difference in the understanding of the engineering drawing. So it is very important to have an engineering drawing with the tolerancing and GD&T to be non-ambiguous and conveying the design intent in a clear fashion. So that's an important skill to develop. Then there is the engineering calculations and analysis, which is also tied up with the problem solving in theoretical and practical way. So engineering calculations and analysis derive from the knowledge, from the engineering knowledge, and how those concepts are being applied and how those understanding of the physics is being applied to the engineering problems. So that's engineering calculations and analysis. That is a specific skill set which has to be developed. Then there is the skill set of DFMA and DFX. So DFMA is designed for manufacturing and assembly. So DFMA skill is developed by having more knowledge in the materials and manufacturing area. So if we know about the manufacturing process very thoroughly, we can design for that in an effective way. And that's how the DFMA skill is developed. Similarly, DFX. DFX is designed for X, where X can be any product requirement. So let's say if you're designing a product for safety, then creating a design such that it is fail safe. So for example, if the product fails in operation, it should not fail in such a way that it causes harm to the user or the customer who is using it. So that in itself is a specific skill set. Like that, there can be different types of design for X. That can be designed for reliability, that can be designed for weight or designed for cost or designed for any product requirement. Then there is mathematical modeling. So mathematical modeling ties into the engineering calculations. So the engineering calculation which we do, the analysis and engineering calculation which we do, if that is automated and made into a computer program, then that can be applied to different types of problems which are similar in nature. Then preparing DFMEAs, that in itself is a skill to prepare a very exhaustive DFMEA of a product such that all of the failure modes, the causes of the failure and the effects of the failure and the remedies of the failure are all covered. That in itself is an important skill which has to be developed for the design engineers. And then there is prototyping strategy. So let's say you have developed a concept or a design which has to be prototyped, but you do not want to prototype the complete concept or the design because it might be costly at that point of time in the product development process. So then which portion of the design has to be a prototype in a way that you can actually evaluate that design in a meaningful way. So those kind of strategies or prototyping methods are a skill which has to be developed by the design engineers, and it comes through practice and experience. So when we talk about the mindset and approach, imbibing the engineering design process is very important. So when we are approaching a problem, whether we are approaching it in the way that we are applying the engineering design process, that is first understanding about the problem, researching about it, and then creating concepts and then evaluating based on the available evaluation methods. So that design process, whether it is being followed as a natural approach. Then what is the creative approach? How are we developing the ideas for solving the problems when it is not a straightforward problem which can be solved? So that creative approach, the ability to think laterally. So let's say if we have to develop 5 different types of concepts for a problem which we are solving. Now, normally it would be very difficult because our normal way of thinking is progressive thinking. We want to think in a progressive way. But if we try to think in a lateral way, then we can develop 5 different concepts solving the same problem. So these kind of things are all come as a mindset and approach which have to be developed through time. So these mindsets, approaches, thought processes are very individualistic. So everyone has a different mindset, has a different approach, has a different taste. So these are something which cannot be easily learned, but which develop through time, through the experience, through doing projects. You develop a taste, you develop a mindset, you develop an approach, which might not be which might not be the same as compared to others, which might be very unique. And that's the reason why we get different types of designs, because everybody has a different approach, has a different thought process. If everybody had the same thought process, then we would be getting the same types of designs around us. So knowledge and skills are something which can be developed, which can be worked on deliberately, and which can be developed. So concept development can be deliberately worked on by doing projects, and we can develop that ability to develop concepts. Problem solving, theoretical and practical, also can be deliberately worked on by taking challenging problems and solving them. CAD also is very obvious. If you practice CAD, you can develop this CAD skill. Engineering, drawing, tolerancing and GD&T also is similar. You have to keep on taking such problems and such projects so that you can practice those skills. So that brings us to the last important point, that all of these knowledge and skills are developed in a best way through projects. So when we are doing projects, you will get the requirement to learn certain knowledge. You will get the requirement to learn certain skills to actually solve those problems. And that's when you actually learn them. If you want to learn in more depth regarding the subjects in design engineering, you can refer to the courses which I'm creating. So I'm creating a knowledge platform which is specially aimed for design engineers to improve their ability to innovate. So that's the mission I'm working for. And I'm doing that through self-paced online courses, which are ranging from mechanical design process, material selection, manufacturing process selection, sheet metal design, GD&T basics, advanced and application, basics of tolerance stack-ups, mechanism design, project-based courses, and even automotive engineering design-based courses like vehicle dynamics, automotive product development, and etc. You can access all of my 19 courses at an offer price in one single bundle. The link to that bundle is given in the description below. I hope this video has been educational to you, and thank you for watching. Bye.